Lesson 4-9, we're going to be using indirect measurement. So we're going to solve problems involving similar triangles. Like to find the height of a tree, most likely you're not going to climb up a tree and drop a tape measure all the way to the ground. That could be pretty dangerous. So we can use other measurements that we know to find the measurement or height of a tree or something like that, like a flagpole, a tree, anything like that, using what we know about triangles, and we're creating similar triangles. So we know that, if we can figure out one triangle's height, we can find out a larger triangle's height, even if we don't know the height, using ratios and common factors and things like that. So for our first example, we will look right at an example of finding the height of a tree. So a tree in front of Marcel's house has a shadow 12 feet long. So when we look at that, we see that the tree is casting a shadow. So the sun is up here somewhere, shining bright, and it's casting this shadow 12 feet long. So as you can see here, we're starting to make a triangle between the tree and the ground, and obviously it goes to the top of the tree because that's where the shadow starts. So there's one triangle, and then Marcel's shadow is 3 feet long. So again, we're using a height that we know. We know how tall Marcel is. So since we know how tall Marcel is, which is 5.5 feet tall, we can use this information. We know that he is 5.5 feet tall, and we know that his shadow is 3 feet long. So we can use this information to help us figure out how the height of the tree without actually climbing up the tree and measuring it down. So again, we have similar triangles here. If we wanted to redraw the triangles, we can. We have 5.5 here and 3, and then we have a larger triangle that we're looking for H, and this one is 12. So again, we want to match these up corresponding. So I'm going to put 3 over 12 for this problem, using the smaller one, the Marcel's height, and the shadow of the tree. So 3 is on top. So if I put 3 on top, I know that I have to put 5.5 on top. So I want those things to match up. And since 12 is on the bottom, I'm going to put H on the bottom, matching up with the corresponding side. So the height of the tree is matching with the height of Marcel. And this is just a proportion that I can go ahead and solve. One thing that I do notice is that to go from 3 to 12, I could multiply by 4. So instead of cross multiplying and dividing, I can just go ahead and take 5.5 times 4, and I should be able to get to my answer just by doing that. So 5.5 times 4 equals 22. So in this case, H equals 22 feet. So the height of my tree is 22 feet high. Now, I know I didn't do cross multiply and divide, which is how we usually solve proportions, but I am still showing my work. I'm drawing this arrow and saying that I can multiply by 4, so I drew an arrow over here, multiply by 4, and that would keep my ratio consistent, because as long as it's happening over here, and if I do the same thing on the other side, we're maintaining the proportional or equal relationship. So Jason casts a shadow that is 10 feet long. At the same time, a flagpole casts a shadow that is 40 feet long. So if the flagpole is 20 feet tall, how tall is Jason? So in this case, we actually know how tall the flagpole is because we remembered, maybe when it was purchased, how tall it is. And we're actually going to use this measurement to find out the height of the person. So typically it's the other way around, but in this case, we're going to actually use this information to find the height of the person. So if it's confusing seeing the diagram like this, just go ahead and draw yourself 2 separate triangles with your known measurements. So we have 20 and we have 40, and that's our flagpole. And then we have the height of Jason, and we have his 10-foot shadow. So we have X and we have 10. So it may help you to write it like this, just to get them separate so you can see them a little bit easier. If you can see it just fine, leaving it as one picture, then that's fine also. So let's get these into a proportion so that way we can solve it. I'm going to go ahead, because these numbers look pretty nice to work with, I'm going to leave 20 over 40. So I'm going to put 20 over 40, and that's equal to x over 10. Notice since I put 20 on the top and 20 corresponds to x has to be on top. Again, I noticed I'm going to have to go from here to here. So when I look at this, I'm dividing this by 2, or from the top to bottom is multiplying by 2. So I could simplify this to be 1/2. So I know that this ratio needs to be equal to 1/2. So I know that x is going to be 5 feet, because 5 over 10 is equal to 1/2. 5 over 10 equals 1/2. So again, however you want to show this, again, you could go ahead and do the solving proportion. You can cross multiply. So we get 40 times x equals 200, and then we divide both sides by 40, and x would equal 5 because we cancel this 0. 20 divided by 4 is 5, and so either way we're getting to the same answer. So just keep in mind that if you notice how numbers are working together, you could avoid having to cross multiply and divide. Otherwise, if you don't notice that, or maybe you don't match them up in that way that it's easy to recognize, just go ahead and cross multiply and divide any proportion that you come across. All right, so a surveyor is looking at the two triangles shown in this figure, and the two triangles are similar. So find the distance D across the stream. So instead of putting a tape measure across the stream here, we're looking at these two triangles. Now, here's our two lines. So angle A is actually congruent to angle E, because there's two lines here and there's two lines here. So D and B are congruent, and then C is actually straight across from each other. So C is congruent to itself. So we need to figure out here which numbers we're going to put with what other numbers. This is kind of a trickier spot here. I know that A and B are connecting my two arcs with my right angle. So I look at my two arcs and my right angle. Two arcs and right angle, that is actually D. So for the sake of doing this, I'm going to match up my 48 with my D. And then since I used the 48 from this shape, I'm going to have to use a measurement from this one. So B and C is 60, so I'm going to put 60 on the top. And then just to make sure I have it right, I'm going to look here. This is a right angle. This is a one line. So right angle and one line is 20. So I'm going to put 20 on the bottom. So just again, make sure that you're matching up corresponding sides. You're not doing 48 and 20. Make sure you're matching them up correctly. Here, let's just, if we want to, we could simplify this. We could by getting rid of the 0. So that could help us there do this a little bit easier. If you want to, now we can multiply across, and we get 6 times D equals 2 times 48. Well, 40 and 40 make 80 plus 16, so we have 96. Then we need to divide both sides by 6. And so 96 divided by 6 is going to give us 16. So across the stream, or across the river, we have 16 meters. And this would be the correct way here on how to show all the work. If you did notice here, we could go ahead and divide by 3. So if you wanted to right here, divide 48 by 3. You can do that. Just make sure you're showing the work, you're showing the step. You're telling me what you're doing, and that will be acceptable as well, as long as you notice what's happening. Or simply just cross multiply and divide. Cross multiply and divide is how you can solve any proportion that you're given. Okay, for example 4, we have another stream problem. It's very similar to the last one. So we're going to look at this here again. We're going to say, okay, P and Q, that's a 2-line, 2-arc, and right angle. So 2-arc and right angle is also our D. So again, I'm going to put 28 and D, and I'm going to match those things up. Since I put my larger triangle on the top, I need to find a measurement there. is 20. We'll put that on the top as well. Those things need to match. I could have put 20 on the bottom if I wanted, or I could put 20 on the top and 28 on the bottom. There's a whole bunch of different ways you could set this up, but it's important that you just make sure everything's corresponding. So now looking at this one, this is a right angle and 1 arc. So right angle and 1 arc is 5. So we need to match that up with D. And here, if you notice, to go from 20 to 5, you can divide that by 4. So 28, we can go ahead and divide that by 4 if we want. And so D equals 7 feet. So to get across the stream, it would be 7 feet. Again, so our numbers matched up pretty nicely. If you had numbers like a decimal or something like that, you're going to want to go ahead and cross multiply and divide to get this problem worked out. So if you want to see an example of that, we can go ahead and do it. We can do 20 times D, so cross multiplying right there, and then 28 times 5. If you want, you can jump on your calculator. 28 times 5, and that equals 140. And you're probably starting to see real quick that we're also going to get 7 by doing this. So the 20s will cancel, and we get D equals, we can cross these zeros out. 14 divided by 2 is 7. So you can see that you can solve this either of these ways. They're both going to work. Just be familiar with doing cross multiplication and then dividing. We talked about it before, being cross products, because any proportion can be solved using cross products, cross multiplication, and then divide by the coefficient, and you'll get your solution. But if you do notice any relationships, you can use that information to solve it a little bit faster and maybe a little bit easier.